Hi, Algebra students. It's Miss Carol again, and we are back for Project 4, Lesson 20, the last lesson in Project 4. So when you're finished with this, you can go ahead and submit the project, and you will get a grade for it. We've only got 4 questions here, and the background is as follows. A forest preserve has lots of different animal species that inhabit the environment. Some of the populations experience yearly growth, while some experience yearly decay. Use your ability to interpret the parameters of an exponential function to draw conclusions about different populations. Okay, so question 1 says, the population of redbirds in the forest preserve is modeled by the function f of x equals 120 times 1.12 to the x power plus 35, where x is the number of years which of the following is true? Okay, so remember that we talked about previously, if it's above 1, if our base, and our base is right here, just in case anybody is unsure, our base is this. How come it's not giving my pencil? There we go. Our base is this. So if our base is greater than 1, we are at growth. And if it is less than 1, we're at decay. All right, so we are certainly at growth because we are at 1.12. And what that represents is 1 plus 0.12, where this is our percentage, okay? So to convert from a decimal to a percent, we would multiply this value by 100 to see that we are at a 12% growth, okay? So we know that it is growing by a rate of 12%. All right, that's all we need to do for that one. Question 2 says, same formula here, f of x equals 120 times 1.12 to the x power plus 35. Then it says, which of the following is true? So let's kind of walk through all of them. The initial population is 35. Well, the initial population might include 35, okay? But our base population that is reproducing is 120, because this is what's growing. We're including this in the population, okay? This is a number that is being included. But let's look at this kind of graphically so we can see what's actually going on. So if we were to put 0 in for x, we would have 120 times 1.12 to the 0 power, okay, plus 35, okay? Anything to the 0 power is 1, so this is 120 times 1 plus 35. And 120 times 1 is just 120, so when we add 35 to that, we get 155. So at time equals 0, our population is up here at 155, okay? So the initial population is not 35, it's actually 35 plus 120. All right, so there we go. We know that neither of these is right, but there are more than one correct answer here. So now we have to look at, well, what number of birds can reproduce? Well, we have to go with 120 because 35 isn't changing at all. That 35 is staying the same. That number right there is going to stay the same regardless of what our x value is, all right? But that 120 is increasing based on what x is, okay? So as x goes up, those 120 birds are reproducing. So we have to assume that those 35 birds cannot reproduce. They're just status quo, all right? Hopefully they're not dying off. All right, so our two answers would be the initial population is 155, and I figured that out by putting 0 in for x, okay? times 0. And then because there's that 35 constant, we can assume that those birds did not reproduce. Okay, question 3 has us doing a little matching problem where we're figuring out which functions work with each. Okay, so for function A, it's a function where part of the population is doubling. Okay, so part of the population. And if you'll remember, we can tell what's going on with a function, whether it's growth or decay, by our base. All right, now I would say that 3 would be tripling and 2 would be doubling. So I'm going to match A up with this. That 3 is part of the population where nothing's happening. Okay, B is a function where part of the population is tripling. There we go. And C is a function where part of the population is being cut in half. All right, so all we had to look at there was that base, whatever number our exponent is being applied to, that's our base. And that's all we really had to look at to figure out what was going on with that exponential problem. Okay, so and just a quick recap, that cut in half, this one would be decay. The other two would be growth. Okay, last question here. Explain how you know your answers to the previous question are correct. What parameters did you analyze? What did we ignore? Okay, so I analyzed the base to figure out what sort of growth or decay I was looking at. I was able to ignore my initial value and the constant value. Okay, short, sweet, that's all I'm looking for. You're welcome to use the exact same sentence, and hopefully it all made sense to you. So that is a wrap for Project 4. Feel free to email or text me or call me if you have any questions about anything that I did in this project, and I will look forward to seeing your work. Thank you.